This video, we're going to introduce the project KarelCraft. So basically, this is an integrated, or at least an attempt for integrating Karel into a Minecraft-like environment using Ursina Engine with Panda3D backend. So just a brief overview. Karel the Robot is an educational programming language for beginners. Although it has evolved a lot, you could also learn it. You could also use it to learn Python, which is popular in data science and machine learning community. On the other hand, Minecraft and other similar sandbox construction video games are popular to gamers and have built a considerable following in the community. So KarelCraft is an attempt to mix the ideas together and perhaps put Karel or put an agent in a 3D world in which the agent could put voxels while the agent or while the user will be able to learn basic programming concepts. So just a brief background. So Karel the Robot can be used as a method of teaching fundamental programming ideas. And currently, in its current version, it is within a two-dimensional world in which this is the agent, this is Karel, and Karel can move forward or Karel can move backward. If in this case, if it moves backward, it has to turn around first and move. So it has its own limitations. Okay, like it could only move forward. So if you move backward, you need a series of commands to be able to perform that action. So it can respond, okay, to simple commands. Okay, but there's no in its original version, there's no turn right by default. And one reason for that is to teach the user to declare functions. So the beginner could declare a turn right function by herself. And you could have a turn around as well. And pick beeper and put beeper. So the empty pair of parentheses, recall that this is used to denote a function. And Karel will also give you some error or some, shall we call a prompt, or if you made a mistake in your sequence of instructions, Karel will tell you that you have made a mistake. So if Karel tries to do something illegal, such as moving through the wall or picking up a non-existent beeper, and so on, so Karel will inform you about the mistake. And this is very nice for beginners if you're just starting to code, in which you are just getting familiar with the concepts of conditional statements and iterations. So it's a problem goal solution approach to programming in which Karel needs to perform a task. Like for example, in this example from Stanford, you have Karel must move one step to this beeper and pick it up, and after that transfer the beeper to a different location in the world. Okay, and together the user will be able to come up with a sequence of instructions to be able to solve the problem. And basically that's the idea behind coding or programming. So you could come up with a sequence of instructions. Sometimes you apply branching and control structures like iteration loops to be able to solve the problem. So for Python, you could have basic syntax like the snake case, turn right, and This is the default, or this is the custom function turn right. And for Java as well, you could learn Karel to, you could use Karel to learn Java language. At least for Python, this is the pattern. So you have def will define a function, the keyword to define a function, and you have main. So this is required in a Karel program. And you could also have a turn right custom function as stated earlier. Karel problems will be able to teach you decomposition. So the process of breaking a program or a problem down into smaller pieces. Like for example, in this case, Karel's first step is to move to the hole. And second will be to fill the hole with a beeper. And then after that, moving on to the next corner. And the student will be able to visualize some of these sub-steps and come up with a different solution, or come up with a solution for each of them, and then integrating it to solve the overall problem. So that's the idea behind problem decomposition. So Karel will also be able to teach a student iteration, a process of repetition or doing something again and again, like the for loop. So in this case, Karel is just gathering beepers and putting it in a certain location. And in this other problem, Karel is just putting beepers at the edges. You could also nest the loop in which Karel will install a certain number of beepers in each corner. And the code is this, like you have a custom function like move to the next corner, put 5 beepers, okay, and then just go to the corners in the main loop or in the main function. And the idea is just solve the problem. While loop is also introduced, a process, again, this is similar to for loop, but in this case, you are testing a certain condition. Okay, you have while test, and in for loop, the usual use case is when you know the number of iterations beforehand. However, in a while loop, if you just want to test a certain condition, it would be ideal to utilize it and just put a termination condition afterwards. A while loop. So Karel is tasked to move while in front is clear, okay, from obstacles. So this move to the corner or move to the wall. So moving to the wall is a simple while loop, and testing the condition front is clear. So the idea behind front is clear is it will simply return either true or false. So if there's no wall, or if there's no there's no item blocking its way, then it will be able to move to the wall. This will be true, front is clear, and perform the move repeatedly. So this is ideal in teaching beginners to learn the concepts of iteration or simple repetitions in a program without too much syntax. So the common pitfall is the Fencepost bug. So the idea is on the last position, usually, if you put beeper, for example, the last position, either the last position or the first position might be vacant because of the Fencepost bug. Like for example, in this case, well, front is clear. If you're putting beeper and moving afterwards, the last beeper will not be installed, or the last position will have no beeper. The idea is this can easily be solved by putting a beeper outside of the iteration, like this one. So basic conditions, so you have conditional testing, like if the test is true, then perform the code block 1, otherwise perform code block 2. and basic conditional statements as well. Like for example, if there is no beeper, you install a beeper, and so on. Okay, and these are basically listed in the documentation for Karel. So let's start with a brief demo. So in this program, this Karel program is simply traversing the world. So the idea is Karel is installing beepers to the corners, and it will stop as long as or after it installs all the beepers. So the goal of the programmer is simply that, and not producing a debug error. Okay, like it finished running and it's successful. So this is a sample solution. So you could have your own default function, you have a main function, and you run the code. So the goal of this project, going back to the KarelCraft, since the current interface is two-dimensional, why not we could transfer Karel or any agent performing the instructions into a three-dimensional world. So that's why this is KarelCraft, and the idea is combining the concepts of Karel the Robot and Minecraft, Minecraft-like environment. Although this is a very small version of it, okay, not at the scale of the existing one, but the basic ideas are there. So in this project, we applied the Ursina Engine, okay, by Poke Peter. Okay, and if we run this code, instead of importing Stanford Karel from the guys in Stanford, okay, we could import this module KarelCraft, okay, which is this one. I put it here, and we could test the perimeter first. Okay, coming up this program, in the perimeter program, I will simply go around the perimeter of Karel and install the blocks. So this is the basic interface of KarelCraft. So you have here the prompt. The prompt will state the current action of Karel, like putting the block or moving or turning left and so on. The position is all stated here. Okay, and you could explore with the speed. Okay, you could make it slower or faster. You could also adjust the camera. So you could come up with a sort of a 2D view of it. So this is just a camera trick. And once the Karel has finished running, you could also explore the world, okay, using arrow keys or WASD keys. And the prompt will also tell you if that location is forbidden. Okay, so this is the sample error scenario if you move beyond the world. Okay, I haven't implemented the walls yet within the world, but executing that will be pretty straightforward, I think. So you could also have the traditional beeper approach. So in beeper, you could stack multiple beepers. So in this case, we could run the beeper. And there is a certain number to it because you could stack beepers on top of each other. So the number in that entity will give you the current number in the stack. So we could adjust the speed and make it faster. So the idea is, okay, we could try to show the stack of beepers So if I delete the termination condition, which is if black present or beeper or if color is present, go outside the loop. So in this case, this will simply be an infinite loop. So we will be able to explore the stacking of the beepers. So I simply put a Z offset. Okay, so you could see that there's sort of a Z offset here. By the way, in Ursina, you could use the right click to just drag the entity and explore your preferred angle. So currently we have 4 beepers in the stack. So let's just stop at 5 beepers for now and move on to other demo. So this is stacking 5 beepers. Okay, and you could simply press escape, okay, to cancel the execution. And as you could see, the beepers here are stuck. So the topmost level is 6. Okay, at least for this part. Okay, however, the other part is 5. And if you move it sideways, okay, you could see that there's a stacking going on because of the Z offset. Instead of beeper, we could also try to use the color. Okay, you could paint a certain color. Let's run this. Make this faster. Okay, so I made it faster, and the idea is it just colors the block. We could also test the multiple objects as you have seen this before, but this time around, we're also removing it. So we're stacking the beepers. Let's make it a bit slower. So in this case, we're stacking the beepers and removing it afterwards. So stacking it, okay, and then removing it afterwards. Okay, we could also test the destroying of the beepers. Okay, in which we put beepers in a line and then we simply destroy it one by one. And it will give you an error if you're removing something that is not there. So error Karel attempted to pick a beeper, but it does not exist. So the reason behind this is you have, at least in this example, okay, we're installing a certain number of beepers. Okay. And then afterwards, we are removing it even if there's no more beepers to remove. So if there's no more beepers to remove, just like the standard Karel, it should return an exception. Okay, I also noticed that if you increase the speed too much, there will be a bug in the collider. So just to avoid that scenario, I just use the data structure and not the collision or not the collider object. Okay, we could also explore the pyramid. So in this case, this is creating a triangle. So currently it's creating a triangle of grass pattern. Okay, I could also modify this. Like for example, for the second level, I could choose maybe a different layer, just pressing numbers. Okay, as sort of the texture, just changing the texture in this case. You could change other. You could add more textures to this. So in my case, I just have. What's the next chapter? You have the brick texture. Okay, so I think I have okay only 5 textures. Okay, but then again, this can be increased. Okay, you could also change the size of the world. Like for example, if in the constants, if we have a maybe a smaller world like maybe 12 by 12, and let's test it with the pyramid. So this is now a smaller world for Karel, and the behavior is just the same. Could change the texture. Could make it faster. Okay. Okay, we could also explore the other commands within my previous discussion, Karel. Okay, so like in this case, we could explore the Karel with different colors. Uh, we could explore the random colors. In this case, these are blocks. So let's cancel it. Okay, because I already converted this to blocks. Okay, let me reconvert it to color. Okay. So in this case, this is the random coloring. And it's currently in staircase pattern. And again, you could explore the 2D camera view and the 3D view as well. Okay, lastly, I want to show you the rainbow pattern as well, or the layered color pattern, which which was shown in the previous video. This one. So it will pick another color for the next layer. Okay. So we could test it to a larger world as well, like could test it to a 40 by 40 world. Okay, hopefully it doesn't break. Let's test it with the rainbow colors. Okay, so this is a big world. So okay, let's reduce this. Let's make the speed faster. So in this case, this will be ideal to use this environment for teaching beginners and let them explore what they could do with the basic computational concepts like iteration and control structures for conditional statements. So this generating certain colors. I could also utilize bricks for this. Okay, and pretty much that's it. And thank you for your time.